You're going to get a ton of work time today. I just thought I'd warm us up and show you a little something new. There's a new worksheet today to add on to that awesome Delta Math assignment. So, but anyways, let's warm up a little bit. Let's do some super easy ones to get started. Let's do like the square root of 84. Huh? Nice. All right. Yeah. So I guess that one was in the notes, huh? My bad. Yeah. So we would have broken it into a root 4 and a root 21, which, yeah, becomes 2 root 21. That's my bad. Today, you're going to see some bigger roots. So there's kind of a couple things. This shouldn't take more than about 5 minutes. There's a combination of a couple new things coming at you today. And I don't know, how did your numbers get really big on Delta Math? Did you get any like really big numbers? Like in the 500s or 600s or 800s or anything like that? Every once in a while? Okay. So I had a couple of them. I jotted them down. Let's try this one. And again, it's okay to use a calculator because we're going to need the assist with as we saturate the red list and we start dividing by this and this and this and this. But don't forget the power of the strategy of just trying to divide by little baby trash numbers. Like the most seemingly useless number is 2. 2's garbage. It's not square rootable. It's like, give me a break. But we like 2 because sometimes if we divide by him, we get an answer that we go, oh, I like that number. Or if we divide by 3, a same thing. We can say the same about like we get things that we like by using little baby numbers that we don't care about. So give it a shot and see what you come up with. Gage? I'm sorry, did you just say 9? So the answer to this is just 9? No. Oh, well, why'd you say 9? So the answer is 44? Okay, I might have to put you on timeout, Gage, if you're going to keep reading random integers to me. Yes. Thank you. Now that is input that I can work with. So I'm going to go branch, branch, root, root. And the calculator guides us and it helps us figure out, like, you divide by 4, you divide by 9, or try the little baby trash numbers. Divide by 2 and 3 to see if something good pops out. But Jesse clearly walked through the red list and tried numbers, tried divide by 4, tried divide by 9, 16, probably not 25. He's too smart for that. And then 36, right? And then eventually Jesse, when he typed it into his calculator, figured out that if you take 36 times 11, you get 396. And that's massively useful information. And it's not just because 36 is on the red list. Remember from yesterday, why do we know that Jesse gave us the perfect and best combination? It's a really important question. Make sure you answer this. If you don't, ask if you're not sure. Why do we know this is the best combo? It's not because it's on the red list. And that's specifically what I said not to do yesterday. Don't consider what you pick the best combination just because it's on the red list. Because I could have found a lot of numbers on the red list, to be clear. I could have divided by 4 and gotten, what would that be? 99, I think, or something like that. Right? So would we have looked at this? We're getting closer. Good. Like, would we have been satisfied with this because 4 is on the red list? No. And why do we know that what I just picked and wrote down over there is not the right choice? Why is 4 and 99 not the combination I would want to use? This is important as you go through and practice with bigger numbers today. Why do I know I haven't found the right combination? It works. You can check it. 4 times 90 is 360, 30. It works. Why is it not okay? Yes, because if the white one, the one that I consider to be my leftovers, has another 4 or a 9 or a 16 or something in it, then I know that I'm going to have to do more work. And like I said yesterday, I don't want to go down this road where I have to double and triple branch things off. So I look at 499 and I say, good job, 4. You're on the red list, but you're dead to me because I don't want to work with the 99. I don't want to have to do another step. So how do I know that 36 and 11 is perfect? Why do I know that 36 and 11 is perfect? Because 11 is a dead root, right? When I can look at this second root and say, you've got nothing else to offer the world, then that's when I know that I have found, or in this case, Jesse has found the right combination for us. What is the square root of 36? 6. So when I can look at the second number and say, you've got nothing else to offer, that's when I know I've chosen correctly. You could have divided this by 4, you could have divided it by 9, but both of those I'd like to think we would poo-poo and say, no, thank you, because I can do better. I don't want that second number to still have any meat on the bone there, right? All right, let's go again. So there was one bit of tutelage that I gave you yesterday, and listen, I appreciate the sentiment because 64 and 9 sound mildly delicious. Like I might order that off the menu if I were feeling a little bit lazy or if it were like some weird Saturday afternoon, but do better. What's the first thing we should always do with a number? You don't see it because it's not on the red list, right? How far up did our red list go? 400. And so you don't have, it's in fairness to you, you can't see this number, but there's a button on all of your calculators that has one of these symbols on it. And it's your guys' job right now to find it on your own individual calculator. So take a moment and figure out where that button is. I will say on most calculators, on the TIs, you have to hit second first. Like you'll see, I think on the TI-30 that the square root button is up above something. You guys know how to, you know how calculators work, right? Like to get, yeah. So like on the TI-30, see the number 7? Go to the left of it and you see the button that says X squared, right? But then if you look above it, you see that in writing, like on the plastic of the calculator, is the square root sign. So what the programmers do is they make every button capable of doing 2 things. So they only need half as many buttons, right? If they didn't smartly do that, then the calculator would have to be twice as big, right? Like a little keyboard. So that's why they give you that second function. So every button can do 2 things. So hit your second button and then hit X squared and you'll be like, oh, that doesn't say X squared. It says square root. So that's how you access the things above the buttons on a calculator. And then just for fun, try typing in 576 and hit enter. And we just discovered that if our red list were longer, if we had done 21 squared, 22 squared, 23 squared, 24 squared, we would see 576 on our red list. So what is the answer to the square root of 576? Just 24. And it's interesting things like if I had done what Jesse said, it's not terrible. I mean, what he said isn't like offensive or anything. If he did the branch, root, and he did 64 and 9, that's your job at that point to look at that and say, hold on, those are both on the red list. Neat. Jesse did us a solid. What's the square root of 64? 8. What's the square root of 9? And what's 8 times 3? It's what we knew it was going to be from the beginning. You should always take bigger numbers just in case and test them and see maybe it is just a square rootable number. And that can save you from the whole tree down process, right? All right. So the last little thing I wanted to show you today. So big numbers, be patient. All right. Use your calculators. It'll help you. The last thing I wanted to show you is you're going to work with problems like this. So if you were taking notes, this would be the new part today. And honestly, it's very, very simple. Obviously, the new guy here is that there's a number in front of the root. So what we're going to do is we're going to kind of take that number and we're going to sort of ignore it. In your mind, you can just kind of take it and place it off to the side. It'll come back in a moment. Let's tree down the number 24. Let's go branch, branch, root, root. There are 3 ways, I think, to multiply to make 24. Which one should we pick? You shouldn't need your calculator for this. I mean, you're in high school, right? Say again? 4 and 6. Yeah, I hate 12 times 2. Why? Neither one's on the red list. And I hate 3 times 8. Why? Neither one's on the red list. So do not pick multiplicative things that don't make progress. But you look at 4 and 6 and say, I'll take it, because if I put a 4 in the first one, which is square rootable, that's not why I know it's the best combination. I know it's the best combination because the other guy, 6, is a dead root. And so I would break this down, and its final answer would be 2 root 6. But then you remember the 8 that I moved off to the side? You guys want to take a guess as to what he does to the final answer? He just multiplies. Yeah, so all you got to do is multiply the guy that was already out front by the guy you broke out of jail. And what is 8 times 2? So we just say it is 16 root 6. The number in front is really just one added little thing that you've got to contend with at the very end. Let's go again. Let's do negative 11 times the square root of 288. Remember, put the negative 11 aside. Bye-bye. Off to the side. Go take a break. And then we have to branch, branch, root, root off of the 288. There it is. And there's really a lot of ways to make 288. You could spend a lot of time coming up with things that work, but then your job is to deduce that they're not the ones you want to pick because they're not the best ones. But Gunnar, I don't know if you heard him up here, he's pretty quiet. He said 144 and 2. We love that combination because 144 is huge and on the red list, and 2 is obviously a dead root. So what am I at right now? Like, what's my current answer? 12 root 2. And then what do I do with that negative 11? You do. So he's just a multiplier in the front. So you take negative 11 and you multiply it down by the 12. What's negative 11 times 12? So our answer is negative 132 root 2. I think you would agree that's really nothing, quote unquote, like new. It's just an extra little step at the end, right? Okay. You guys have any questions? Anything that was getting you yesterday? Always remember to check if a number is square rootable. If you don't know where your square root button is, just let me know and I'll show you. Most calculators, it's really easy to figure out. And that's that. So you're going to work on your Delta Math, the big long 60 question, and then I've also got a paper worksheet that introduces the numbers in front. That's what you'll be working on today. So let me show you a couple of different approaches. The first approach is just the brute force method, where I just faithfully attack the red list. So grabbing my calculator, I type in 108 divided by 4, and I figure out that I can do, and I'm not going to write in red. I'm just going to be quicker with the white pen. I'm going to do 4 times 27. And your question is like, okay, that works. How do I know if that's the best one? Well, look at the number 27. Could you break down 27? How? And 9 is on the red list. The fact that you could do that means that 4 is of no use to us. If the second number still has life, then I know to press on. So what I do now, when I'm looking at my red list, is I can take 4 and I can say, okay, I've tried you, but I know you're not the best. So I don't do 5, 6, 7, or 8. Then I grab my calculator, unless you just know your times tables well, and I divide 108 by 9, because 9's the next number that I care about, right? And when I divide it by 9, then I figure out that, hey, that also works too. I can do a 9 and a 12. So I feel like we're getting better here. But again, I must ask you, and that for the same reason that we knew 27 was not what we wanted as a leftover. Why is 12 not something we want as a leftover? So the fact that you can keep pulling out more red list numbers means you haven't gone far enough. And then you grab your calculator and you keep going through the red list. And then you try 108 divided by the next number that we care about, which is 16, and you get a decimal. So you know 16 won't work. I don't think you would even divide it by 25 because it ends in an 8. Like, how could anything with an 8 divide by 25? And then you move on to the next one on the red list, which is 36. You see what I'm saying? I'm just brute force attacking each number from left to right on the red list. And when you divide by the next one, which is 36, you find your third success. And this time I know it's the right one because tell me about this one. It's dead. And I know Mr. Roscoe used that term earlier. Try using that. That being a dead root is really important. A dead root means it can't break down using red list numbers anymore. Do you understand? So the question of which one of these is the best is hands down this one. It takes us now. I'm going to show you a quicker way to do problems like this. So because you don't the best way to do these is not always to brute force checklist your way down the red list from left to right, because that can take a while. So another thing we like to do is take the number 108 and divide it by little tiny numbers that don't mean anything to us. They're what I was referring to yesterday as baby trash. 2 is a baby number and it's trash. It's not on the red list. It's a useless pile of dung, right? But my point is that if I divide it by that, the other number that I get might be something that I'm interested in. Do you see what I'm saying? I'm not directly looking for red list numbers in the way that we did a minute ago. I'm looking to see if maybe I can find one sort of by the back door. If you divide 108 by 2, you get 54. 54 is not on the red list. I'm not interested. And then you divide 108 by the next baby trash number, which is 3. Again, 3 is dead. I don't care about 3. But what I do care about is when I divide 108 by 3, I get 36. And this has to trigger a big bell, a big loud bell, right? So rather than just go divide by 4, divide by 9, divide by 16, 25, 36, 49, because that could take all day. Sometimes it's quicker to hit it with little random division problems in the hopes that the other number that I get will be a big glorious thing like 36. Does that make sense? You sure? So you know you found the best one when the leftover number is dead. Got it? Okay.